Let's talk about factories, but probably not the kind you're thinking of, with smokestacks and sprawling buildings. What if the next huge leap forward in making things isn't happening on Earth at all? We're talking about manufacturing in space. And this is rapidly shifting from the pages of science fiction into a very real, very tangible industry. So let's get into how this is all happening. I love this quote. It just perfectly captures the vision, right? Imagine that for a second. These bright, silent workshops just floating up there. This isn't just some poetic dream anymore. It's basically the blueprint for an industry that's being built as we speak. And it all hinges on one single, incredibly important principle. Okay, so you're probably wondering, why on Earth would we go to all the trouble and expense of building things in space? Well, it all comes down to this idea: the microgravity advantage. For years, being weightless was seen as this huge problem to solve. But now, the thinking has completely flipped. People realize it's not a bug, it's an unbelievable feature, a manufacturing tool we just don't have down here. So what is microgravity, really? Well, it's just what it sounds like: an environment where gravity's pull is so tiny, it's pretty much a non-issue. And that simple fact changes the entire game. Without gravity yanking everything down, materials can mix together perfectly uniformly. Crystals can grow to be absolutely flawless. Liquids, left to their own devices, will form perfect spheres. It unlocks a level of perfection that is physically impossible to get on Earth. And check this out. This chart lays it all out, plain and simple. Down here on Earth, gravity is the boss. It causes convection, it causes sedimentation, when the heavier stuff sinks to the bottom. It introduces tiny defects and weaknesses into almost everything we make. But in orbit, all of that just goes away. You get perfect mixing, consistent composition, flawless structures. You're fundamentally changing the rules of physics for manufacturing. All right, so we've got this amazing gravity-free playground. What can we actually build in it? This is where we get to the really cool stuff, what some people are calling impossible materials. These are the hero products, the things that are so valuable and so high quality, they literally can't be made anywhere else but in space. And right now, the undisputed star player, the poster child for space manufacturing, is a material called Z-band. It's a very special type of fiber optic cable. The problem is, when you try to make it on Earth, gravity's pull causes these teeny tiny crystals to form inside the glass, and those little imperfections wreck the signal. It's like having a little bit of static on the line constantly. And this chart, wow, it shows you just how big a deal this is. It's measuring signal loss, and obviously, lower is way better. Your standard fiber has a pretty high loss. The Z-band we can make on Earth is better, for sure. But the Z-band made in space, it's on another level entirely. The performance is orders of magnitude better. We're not talking about a small incremental improvement. This is a leap that could power next-generation internet, supercharge AI data centers, you name it. And it's not just about faster internet, not by a long shot. The possibilities are kind of mind-blowing. We're talking about ultra-pure metal alloys that are way stronger and lighter for things like jet engines, flawless semiconductors for the next wave of computer chips. And get this, in medicine, they're working on printing perfectly uniform layers of protein for retinal implants to literally help restore people's vision. They can even build huge, delicate things like giant telescope mirrors up there so they don't get crushed by the force of a rocket launch. Okay, I know what you're thinking. This all sounds fantastic, but also insanely expensive. If it's so great, why are we only doing it now? Well, the answer, like it often is, comes down to money. We've finally hit an economic tipping point. That massive cost barrier that kept space manufacturing in the realm of theory for decades, it's starting to crumble. And this number right here, this is the magic number. Getting the cost to launch 1 kilogram to orbit below $500. This is the threshold that changes everything. And thanks almost entirely to reusable rockets, it's finally cheap enough for companies to make a serious business case. It's now actually profitable to make these super high-value things in orbit and bring them back down. And things are moving fast. I mean, look at this timeline. The very first 3D printer in space was installed on the ISS in 2014. That's really not that long ago. Today, we're at over 200 parts printed. In just the next year or two, we're expecting the first commercial Z-band production facilities to launch. And by the time we hit the mid-2030s, this isn't an experiment anymore. It's a full-blown, multi-billion-dollar industry running on private space stations. So let's pull back for a second and look at the big picture here. This is about moving past just doing one-off experiments on the International Space Station. We are right on the verge of creating an entirely new industrial ecosystem. one that just happens to be floating a few hundred kilometers above our heads. So what's the game plan? Well, it pretty much unfolds in 4 key stages. Step 1, launch and deploy. You send up the robotic factories and all the raw materials they need. Step 2, autonomous production. These things just work 24/7 with very little human help, cranking out these valuable products. Step 3 is the supply chain, return and resupply. You have vehicles bringing the finished goods back to Earth and taking new materials up. And then, step 4 is the real leap, sourcing materials in space, from the moon, from asteroids, creating a truly self-sustaining off-world economy. Now, let's not get ahead of ourselves. This is not easy. There are still massive challenges. I mean, how do you make sure a robot works flawlessly for years in a vacuum with no one to fix it? How do you get something incredibly delicate back through the atmosphere without breaking it? Not to mention radiation and even legal questions, like who owns what in orbit. These are huge, complex problems that brilliant people are working on right now. This is a real frontier. Which really leaves us with this one final, pretty big thought to chew on. Every major industrial revolution in human history was built on things we could dig up or pull out of the earth. So the big question is, will this next one be defined not by what we can take from our planet, but by our ability to leave it?